Okay, in this video, I will go through the Set 3 Express Term 4 2022 paper. I will cover question 3 and 4 in this video. So for question 3, I'm checking whether you can use vector diagram to actually find the sum of two vector. So in this case, this two vector is 240 Newton and 40 Newton. And in the question, they actually tells you that theta is 35 degree from the horizontal. So there are two approaches to it. You read it vertically down. So I think just having a look, you will be able to tell the difference. So in approach A, I start off with the 400 Newton pointing towards the northeast, right? Then after that, I am going to draw the 240 Newton right after the 400 Newton, which is this yellow one. So by doing this, you can connect the resultant vector, which is the F net, from start, which is here, to the end, which is here. Yeah. There's another approach. So in approach B, what I did is that I start off with the 240 Newton vector, which is pointing to the northwest, this guy over here. Yeah. Then after that, at the end of the 240 Newton, I add in the 400 Newton vector, which is over here. Yeah. So this is pointing to northeast, and you can see that I draw the 400 Newton here pointing to the northeast as well. So both methods will actually give you the same resultant vector. Now, after you draw the vector diagram, the next part of the question is actually checking whether you can visualize how the vector diagram would change when one of the angle, in this case theta, is going to get increased from 0 to 90. So theta is actually located here, here, and you can just imagine what will happen when this theta gets moved to a larger angle. So just imagine having a circle being drawn over here, and then this vector just sweep along this arch, right? Because theta is increasing. So as a result, you can see that your F net will also be moving like that, right? So you can see that your F net, just by visualizing it here in approach B, you can see the F net actually become longer as your theta become a larger value, right? So basically, most question in your end of year will be, in your end of year, not most question, in end of year, some questions will be like this, right? They ask you to do a sketch, to do a diagram. Then after that, in one of the later part, they will ask you like, oh, what if this parameter change? How will that affect one of the parameter? And actually, the intent of asking you to sketch earlier is to actually guide you to, hey, you can, after you write, you remember what you just did, you can use that diagram to help you visualize and answer the later part of the question. So in your end of year exam, you will see some of these practices here. Yeah. Okay, then after that, for question 4, question 4 is a question on kinematic, and we have practiced this in your summative worksheet. So down here, you should know that for this particular thing, it is spinning constantly. So there is never a time whereby your V will become 0 meter per second, even though there are turning points, there are maximum height and all that, because the cabin is moving constantly, right? So as a result, the magnitude of the velocity will always be constant, right? Because the magnitude of velocity is given by speed, right? It's magnitude, so it will always stay at 0.25. Now the thing about velocity is that it also has a direction component, right? And because it is moving in a two-dimensional way, what do I mean by that? Now in some question, for example, if you have a car, then this is a one-dimensional motion, because your car can only move forward and backward, and you can assign a positive sign here and a negative sign here, and it tells you the direction mathematically. In another word, for example, I can give you another one. For example, let's say I have a rocket moving, and it is moving either up or down. So this is another one-dimensional object, and the direction of velocity can be simply be assigned a plus and a minus, and you can denote it. So for this example, what happened is that the cabin is actually moving in a circular way, And when you move in a circular way, it is not either up or down, left or right. It is actually moving on a plane. And this plane, right, can be defined by a y coordinate and an x coordinate. So you can imagine this thing like that, right? And it is moving everywhere along this plane. So this kind of motion, we call it two-dimensional motion. And for two-dimensional motion, you can no longer describe the direction of a vector simply by plus or minus because it has two dimensions, right? You can go either up, down, left, and right. So you have four choices. But for one-dimensional motion, you only have two choices, right? Horizontal, let's say this case, you have two choices, forward, backward, right? If it is a vertical one-dimensional motion, you also have two options. Either you go up or you go down, right? But for two-dimensional motion, right, you can either go up, down, left, or right. So you have four options. So plus and minus will no longer serve its purpose. Now, to describe the vector the direction of a vector moving in two-dimensional motion, you need something called polar coordinate. So in a polar coordinate, what happens is that there will be a number to represent its magnitude. So in this case, the magnitude would be 0.25, and then there will be an angle, and it is written in this way. You do not need to know how to operate this because mathematically you have not been introduced to it. But you need to know that the direction of a vector is given by an angle, right? So for example, down here, if I want to know the direction vector, the direction of this velocity vector, it will be tangential to the curve. So this is the curve, and the direction will be tangential to it, and we can actually assign an angle to this. For example, in this case, 90 degree, right? So as the cabin moves to a new location, then at this particular point, what would be the direction of its velocity? It will be tangential to the curve over here, and this direction can be denoted by this angle over here, theta, right? Then after that, as it moves to here, you will have another angle. Move to here, it will be another angle. Move to here, it will be another angle. Then move to here, it will be another angle. Move to here, it will be another angle. So what happens is that as if you have an object moving in a circular path, you can see that the direction component of this vector will be always changing, right? It is neither increasing nor decreasing, right? It is just changing from 0 to 360 degree and then reset back to 0 degree. So we say that the direction component of this vector is always changing, right? Then for the part B, I think it is pretty straightforward. The key thing is that you need to remember to change your time from minute to seconds because the speed given to you is in meter per second. So down here, if you didn't change this into second, you will find that the distance you find will be wrong. And you also need to know the distance moved is actually the circumference of your merry-go-round. So circumference is given by pi d, not pi r square. Okay, so if you go and work this out, you'll be able to find the diameter of the merry-go-round. Yeah, so I will stop here, and you can watch the next video to cover